The AnomAlert Motor Defect Simulator provides electrical and mechanical fault simulator functions. It is based on advanced hardware and professional design. It is flexible and robust, cost-effective and useful for demonstrating the functions of AnomAlert for training purposes. It is a handy, easy-to-use simulator which can be useful in training personnel for the operation of AnomAlert and for the use of AnomAlert in diagnosing machine anomalies. The main differences between the Pro and the Lite version of the AnomAlert Motor Defect Simulator is that the Pro version features a built-in industrial PC running an AnomAlert server. The Lite version does not have a built-in PC. Here we have the AnomAlert Motor Defect Simulator. As you can see, this enclosure contains all of the hardware necessary to simulate an operating environment for the test motor. It also contains an industrial PC running the AnomAlert server software so that this AnomAlert test unit can be interrogated from anywhere in the world with an internet connection. Here on the lower half of the panel we have the controls necessary for introducing simulated faults on the test motor. We also have some indication. We can see here there is current per phase and also phase voltages. Along here are the push buttons for introducing electrical faults. We can introduce a turn fault on either U, V or W phase simply by pushing the simulation start button on the corresponding phase. Resetting is as simple as pushing the normal state push button. We can also introduce earth faults. At the flick of a switch, an earth fault is introduced on the test motor's stator winding. There are two levels of earth fault, fault 1 and fault 2. These simulate a higher impedance fault and a lower impedance fault. The test points at the bottom of the cabinet are used for connecting external measurement equipment so that the faults and their nature can be independently monitored with test instruments and the outputs from the AnomAlert verified. Here we have up close the test motor. As we can see, the test motor is a small 3-phase 180 watt induction motor. This motor has been rewound with a number of extra taps in the stator winding so that stator earth and turn-to-turn faults can be simulated. This motor is coupled to a hysteresis brake. The hysteresis brake is used to simulate a load. It is controlled by an electronic brake controller so that precise load profiles can be simulated. Welcome to the AnomAlert software. Here we have the overview page. This page represents a quick summary of all the connected AnomAlert units. To the left we have an equipment tree detailing information on all connected units. As can be seen here, there is only one device currently connected. This is the training simulator we have just seen, which is based in Pinkenba, Brisbane. To the right hand side of this window we can see a summary of the equipment status and a summary of the electrical values. The spectrum page of the AnomAlert software shows the PSD plot, or power spectrum density. It is from this plot that mechanical faults are determined and derived. The various frequency bands are usually indicative of different mechanical problems. For example, the one under the cursor at the moment usually indicates issues with unbalance, misalignment, coupling or bearings. The report page of the AnomAlert software generates an automated report for the device selected. It can be seen here that the selected device is the training unit based in Pinkenba. The left hand side panel shows a summary of information on the unit being reported. To the right hand side we see a summary of faults on the unit. This is the Control tab. From here the AnomAlert unit can be directly interrogated and operated as if you were touching the front panel of the device itself. It can be seen that all of the machine parameters and settings can be adjusted and interrogated remotely. I am now going to introduce a turn fault on U phase. Here we have the overview page again. As can be seen here, the turn fault that was introduced previously has shown up as a watch. Every 90 seconds, AnomAlert calculates the parameters of the connected motor or generator and compares these values to its learnt model values. After some time, when statistical persistence criteria have been met, this watch warning will be elevated to an equipment status alarm and be flagged in the upper window. From this page, the trending for the appropriate alarms can be directly accessed. By double-clicking on the watch criteria, it takes us to a trending page showing the current balance values. It can be seen that by introducing the fault on the machine, we have caused a large rise in the current imbalance. This has been detected by the AnomAlert unit. Here we can see the AnomAlert unit is now indicating an alarm. This is due to the previously introduced fault having met the AnomAlert persistence criteria and being elevated to an alarm condition. Now back on the reports page of the AnomAlert software, it can be seen that one fault has been reported. This is described by the unit as a current imbalance exceeding 5%. It recommends to check for stator problems, short circuits, insulation problems, or partial discharge. It can be seen that short circuits is identified as a probable cause. This is accurate as a short circuit was deliberately introduced into the test machine.